Today's video, it's all about a catchy title in my video, weigh or by volume. Now, the three reasons why I wanted to make this video, and the first one is it's the most frequently asked question I get, weigh or by volume. The second reason is, long before I was on YouTube, a friend came around and watched me use epoxy resin with sand, and he used it, but he had a lot of failures. So the video is to show you how not to make those failures. And the third reason is, a long time ago, about 35 years ago, I decided to use sodium silicate for moulds, and when the chemist showed me how to do it, I was lucky that he gave me some good advice. When I was in his laboratory, he said, never use volume to measure your ingredients. Always weigh them. So that's good advice, and I've followed that over the years. And I'll show you just how important that is with some experiments. This is experiment number 1. This container is 0.4 of a litre. So what we'll do, we've got my cast iron cannonballs, we'll put one in. Now we'll put the second one in. As you can see, it doesn't fit in. So if I take that out, that is legally in volume 0.4 of a litre, even though there's a lot of air gap in there. Now you might think that's an extreme experiment, but it gives you an idea of the next few experiments to see exactly what happens. This is experiment number 2. Now what I'll do, I'll fill it up to the legal level. I'll show you, just overflow a little bit, and then we'll use the strike bar and we'll bring it back to level. Now legally that is 0.4 of a litre, but this can be subject to interpretation how well you actually clean the top off that sand. Now this is the other part I wanted to show you. Just watch this. There. Now if you wanted to make that 0.4 of a litre, you'd have to go and stick again and level it off. Now that's why you don't use volume, because it's subject to interpretation and you'll get problems like that. And there's even more problems, and I'll show you in the next couple of experiments. This is experiment number 3, and it'll show just how different two samples of sand can be. This one here is a professionally graded sand I got from a foundry, and this one here is what I use for the iron sand. It's really cheap sand, $10 for a tray load I get from my local sand pit. To show you the difference between the two sands, I'm going to use an old film container, and I'll fill it up full of sand and then weigh it, and we'll use the professionally graded sand first. So 50 is not enough. So 43 is a little bit too much, so I'll go back a bit. So I'll go to 42. Yeah, make it 43. So that sample weighed 43 grams, or just over. Now we'll do the same thing again. We'll use the film container and we'll use the cheap sand that I got from the local sand pit. We'll just level it off. Then we'll put it on the scales. So what I'll do, I'll put it to 43 where it was for the last sample. No, this one weighs a lot more. So we've got 48.85 grams. Now, as you can see, both those containers were the same volume, but the weights were very different. That's a huge amount of difference between those two different sands. Now I'll show you just how different these two sands are. This sand is a commercially graded sand, and the grains of sand are like this cast iron cannonball. They're very smooth sides, but they look roughly like an egg shape, not like a sphere like this one here. And this one here is the cheap sand I got from the quarry. What it looks like under a magnifying glass, it's very rough with jagged edges like that. Now that sand, because it's got smooth edges on it, it will use far less binder than this will. So with the professionally graded sand, I use 1.5% by weight of resin and hardener. This one here, it's between 1 3/4 and 2%. If I try to use 1.5 with that one, it's a very crumbly core. Now two other things I'd like to say. When you buy petrol, if you buy 20 litres on a stinking hot summer's day and then let it cool down on a cool evening, and then the next morning measure it again, you will have far less than 20 litres. Now petrol is measured by volume. But also, if you go to a scrap metal dealer and you sell scrap metal, he will always weigh it. You'll never use volume. It's just a couple of examples I thought I'd show you and have a think about. So here we go. We're going to mix up some sand, but before we do that we need to know how much. So this is how I do it. Just tip it in like so. And then you just give it a bit of a tap. And then you put a bit more. Another tap. And then what I do, I just lift it up. And drop it in the mixing bowl. Now here is another reason why you would weigh a liquid instead of using or measuring by volume. Now the sand's in here, it's usually in there and on the scales, but it's easy to show you. So what I do is put a slight depression in there, so when you tip your resin and your hardener in there, it does not touch the sides, because what happens is if it touches the sides, you've lost a bit of your resin and your hardener, and it's not going in your sand, so you've got to keep it very dry. Alright, the right amount of resin is on there. Now what we'll do, cover it up so when we transfer it into the mixing bowl, it's just an ice cream container, it'll be covered in sand and the minimum amount of resin will touch the sides, so we'll keep the exact mixture we want. There's only 2.1 grams in that mixture, so if you spill a little bit on the sides you can get a lot less resin and harden it to actually go into your sand. So before I dump it into the bowl, I give it a bit of a mix like that to make sure that the sand is attached to the resin, and then in a fairly quick movement like that, there you can see it's in there. Now that blob of resin is still very sticky and hasn't got any sand attached in the middle, so what I do, chop it up in little pieces like that. And how you properly mix the sand is you rub it like so. That might take a few minutes. Now I'll show you what happens when the mixture is not mixed enough. This is what happened to my friend. Now if I run it through a sieve like that, you can see all those balls there. That's unmixed resin and sand. Very high concentrations of resin and probably a little bit of sand. And what happened to him, because it was a lower mixture, the sand was very crumbly in his cores, but also it caused blows in those areas. So what you've got to do, you've got to put that back in again and keep mixing until there is no balls like that. This is the easy part. Just add the sand, keep ramming it in there. And for cast iron, I always recommend to put a reinforcing wire down just to give it that extra amount of strength. And you're probably wondering why I've got that blue lid there, because when you spill it, it's just as easy to go like that, use the last amount. The beauty with epoxy resin is you've got plenty of working time. But the downside is it takes a full 24 hours or probably a lot longer in cold weather for the core to be fully hard and ready to use. So to accelerate that, I use these old fan heaters. But one thing you've got to watch, you've got to keep rotating your core around so one part doesn't get too hot, because the actual mould is made out of PVC. And it will soften and you'll probably distort the core and your mould and won't be able to use it again. I'll see you in about an hour's time. The core, just tried it, it's nice and hard, and now we'll release it. There's a finished core. A final note for the video, you noticed I said 1.5% by weight to sand. Well, what happens is that works well with my sand, and as you can see in the middle of the video, two different sands can give widely different results. So what I suggest to you, if you use this method, try 3%. That's what I did when I started. I used 3% and then gradually moved down to a lower amount until the cores were so fragile they just couldn't be handled. So there's a way for you to test it and to use this method.